So we're going to work through problem number 61 here. And as you can see, it is a coffee cup calorimeter problem. So we're going to start with saying Q equals MC delta T for this particular problem. And we can see here that temperature starts at 22.6. It is going up to 23.4. So we know that delta H is going to be negative. And so now let's talk through how to solve this. We're going to assume that the combined mass is 100, has a specific heat of this. And so if we look at Q is going to be equal to 100 times 4.18 times our change in temperature, which is 0.8, not 6.5, as I said earlier. And so if I look at that, I'm going to get a Q that equals 334.4 joules. Now that is not our delta H, because that is just the amount of energy that was made when we mix these two solutions together, and we want it to be in kilojoules per mole of AgCl produced. Now in this particular reaction, we can see that there's a 1-to-1 relationship. If we were to write out the total balance equation, we see AgNO3 plus HCl is going to give us AgCl plus HNO3. And so everything's in a 1-to-1 relationship. So, and if we're looking here, we're adding equal volumes and equal concentration. So really we know that we got 0.05 liters times 0.10 moles for every 1 liter, and that's going to give us our 0.005 moles of both reactants. And since it's in the 1-to-1, no matter which reactant, we're going to get 0.005 moles of AgCl. So that's how many moles of AgCl we have there. So if we go back to our Q, if we want to figure out what delta H is, we know delta H is going to be negative because the temperature increased. And in here we know that that's going to be 334.4 divided by 0.005. That's joules. This is moles. That's going to give us a negative 66.880 kilojoules. Oops, sorry, I lied. That would be joules per mole, which we then would convert to our negative 66.9 kilojoules per mole. So that's how we would work number 61.